Why is the interrupt vector table essential for interrupt handling? Imagine you're trying to catch a bus, but instead of waiting at one stop, you have a map that instantly shows you where each bus is headed. That's what the interrupt vector table does for a microcontroller or processor. It acts like a quick reference map that tells the system exactly where to go when an event happens. When a hardware device or internal process needs attention, it sends an interrupt signal. The processor then needs to know which piece of code to run to handle that event. Without a clear plan, it could waste time searching for the right response or get confused about what to do next. The interrupt vector table is a list stored in memory that holds the addresses of all the interrupt service routines. These routines are small pieces of code designed to respond to specific events like a timer finishing, data arriving on a communication port, or a sensor detecting something. When an interrupt occurs, the processor looks up the corresponding address in the table and jumps directly to that routine. This quick jump is what makes the system responsive and efficient. One big reason the table is so important is because it allows for fast access. Instead of searching through a long list or polling devices to see which one needs attention, the processor can go straight to the right code. This reduces delays, which is vital in real-time systems where every millisecond counts. The table also keeps things organized by centralizing all interrupt addresses in one spot. This makes it easier to update or change responses without messing up the entire system. Many microcontrollers expect the interrupt vector table to be at a specific location in memory. This standardization helps hardware components work smoothly together. When the processor sees an interrupt, it automatically knows where to look in the table, making the whole process seamless. Programmers can also modify entries in the table to change how the system responds to certain events. This flexibility is useful for customizing behavior or updating firmware. In systems with multiple priorities, the table helps manage which interrupt gets handled first. Higher priority interrupts can be assigned their own unique addresses, so the processor can respond to the most urgent events immediately. This setup allows for nested interrupts, where a new, more important event can interrupt a current routine. Since interrupts happen asynchronously, meaning they can occur at any time, the interrupt vector table ensures the processor can respond instantly and correctly. Whether it's a timer expiring, a data packet arriving, or a fault happening, the table guides the processor to the right response. Without it, the system would have to rely on slower methods like checking each device one by one, which would slow everything down and make the system less responsive. In embedded systems, this quick response is what keeps things running smoothly. Sensors can alert the system immediately when they detect something, communication can be handled without delay, and user inputs can be processed swiftly. The interrupt vector table is the backbone that makes all this possible. It provides a reliable, organized, and fast way for the processor to handle multiple events efficiently. That's why it's so essential for interrupt handling in electronics and embedded systems.